right, so we're going to be talking about section 1.1. Of course, before I started, we had a discussion in class about some of the best prom attire ever, which of course was in the 1980s, and I wanted to show you just maybe what your example should be as you're heading into prom season now, and what your ultimate goal should be is to look maybe as good as some of these ladies looked. All right, so we can have two things that we're going to get through today, and one of them is that we're going to use the properties of exponents. We're really going to kind of get clear on them. It should be a review, and we're going to look on solving equations using rational exponents. We're really looking more today about just the properties of exponents. This is from page 696 in your book, and the book does have some good examples. We'll do a few examples. Most of the examples I'm going to be doing are from the examples from the worksheet that you were given. So when you have a common base, our big thing that we're looking for here is that you have a base and then you have it raised to an exponent. All right, so you need to be common with, okay, we're talking about a base raised to an exponent. If you have a matching base, kind of like what you have here in our numerator, the rule is that you add the exponents. So this would be 2 to the 12th. If you are dividing two of the same base, like matching bases, and you're dividing, then you actually subtract the exponent. So our answer here is 2 to the 7th. When you have parentheses like you do here, you apply the parentheses, this exponent in the parentheses, to everything in your base. So it would be like 2 to the negative 1 and 5 to the negative 1. Now we come to the problem of what do we do with a negative exponent. A negative exponent, you actually jump the fraction bar, so it actually moves from where it is in a fraction to the opposite value. So if it's in the numerator, it goes to the denominator. If it's in the denominator, it goes to the numerator. So here, this 2 would go to our denominator, all right? And here it's going to be 2 to the first in the denominator. That's how we make it a positive exponent. This 5 to the negative 1 is going to move here to our numerator and become 5 to the first. So our answer to this fraction would be just simply 5 over 2. So let's look at some other problems here. Following the same rule we just talked about, if we have 3 of the same bases and we're multiplying them, you actually are going to add their exponents. 7 plus 3 plus 2 is y to the 12th. If we have one base and two powers, this is called power of a power, you actually end up multiplying the exponents. You actually can think of this as n to the 6 times n to the 6 times n to the 6, which if we added them all together is going to give us that n to the 18th. Here when we add these two together, we get p to the negative 4th. Then we have to deal with the fact that we have a negative exponent. So this is, we got to think of it as a fraction first, and then we have to think of it that, okay, we're going to have that fraction jump to the opposite part, and so it's p to the 4th in the denominator, and then our numerator would have to be 1. In number 4, I kind of think of my different bases as having kind of a barrier. You kind of deal with them separately. So in my head I see this. I see 21 over 35 that I need to reduce. I divide both the numerator and denominator by 7. And so I got 3 over 5 there. And then I see the y to the 9th over y to the 3rd, kind of a separate problem. And I know that this is y to the 6th. So my answer becomes 3y to the 6th over 5y to the 3rd. So I kind of see this as taking away 3 y's here, or y to the 3rd. If I took away 3 y's here, I'd have 6 y's left. So that's kind of how I thought of that. This problem here is really testing your knowledge of having 0 as an exponent. Do you know or do you remember the fact that when you're anything raised to a 0 power is simply 1? So our answer here is really just 5x to the 4th. In this problem, we're going to have the step of when you have an exponent, everything in the parentheses prior to that exponent is taken to that exponent. So this would be 3 to the negative 4, m to the negative 4 over 2, and then we have m to the negative 4. My next step usually then is can I take each, or can I move all the negative exponents and make them positive exponents? So I'm kind of look at this 3 to the negative 4, and I would say to myself, oh, I need to put that in the denominator so it becomes a positive 4. I'd look at this m to the negative 4. I'd need to put that in the denominator to make it be a positive. The 2 that was over there is already in the denominator. It's already positive. This m to the 4th, negative 4th, would move here to the numerator to make it positive. Then I'd see, okay, what can I reduce? I can reduce these two m to the 4s, and I need to take 2 times 3 to the 4th. 3 to the 4th is 81. Multiply that by 2 and we get 162. All right, so some more examples here. I'm going to kind of pick and choose. We'll look at 7. Now there's no parentheses here, so we have no parentheses that we have to deal with, but we do have negative values that we're going to deal with. So for every negative value, I'm going to move it to the other part of the fraction. So at the 6x to the negative 2, I'm going to make it, excuse me, I kind of had a miswriting there. I'm going to make it 6 to the positive 2 in the denominator. The x to the 4th was already positive, so I'm going to leave it where it is. The 2 to the negative 3, I'm going to make 2 to the positive 3 in the numerator. And then that x to the negative 3, I'm going to make x to the positive 3 in the numerator. So I kind of moved everything around. I just started by just rearranging everything. So now my problem becomes 8x to the 7th, I'm combining like terms, over 36. Now this 8 and the 36 here can be reduced further. I can divide both the numerator and denominator by 4. And so now my final answer becomes 2x to the 7th over 9. And that is my final answer there. Let's jump down to number 9 here. The first thing I'd want to deal with is this 4 right here. All right, so I'm going to have to take everything in that denominator and take it to a power of 4. So that would be x to the negative 12. It wasn't affected by this, or this y to the negative 2 wasn't affected. And really these 4 parentheses are really not necessarily not supposed to be there, but they're not useful to us. So I'm going to kind of just rearrange, and I'm going to put things in order here, but I'm just kind of moving around. The parentheses doesn't matter. It's all multiplied together. So now I'm going to take everything, and anything that has a negative, I'm going to put it to the opposite area. So if it had a negative exponent, I'm going to move it to the other side of the fraction bar. So the 3 and the 5 were fine. The x to the second, negative 2, I'd make it x to the second in the denominator. The x was fine there. The y to the third was fine. The y to the negative 8th, I'd make it y to the positive 8th there. This x to the negative 12th, I'll put it over here. I got to have a spot for it, x to the 12th. And then that y to the second there, I need to put it in the numerator. Now I have all positive exponents, so now I can kind of combine like terms or simplify by multiplying. So I have 15, I have x to the 13th in the numerator, and I have y to the 5th. In the denominator, it turned out to be x squared and y to the 8th. I'm kind of running out of space here. The 15 remains. There's nothing to reduce it, but with the y's here. So now I kind of think of it like this, my x's. My x to the second, I can think of it as I'm taking away 2 x's from the denominator, and if I took away 2 x's from the numerator, I would have here x to the 11th left in the numerator. In the other problem, if I took away 5 y's here, and if I took away 5 y's here, I'd have 3 y's left on the denominator. And that is my final answer. Let's look at number 11. I'm kind of jumping around here. I want to look at 11 and 12. So let's look at 11. My first step with 11 would be take every single term to that negative 3. So I'd have x to the negative 3, and then I'd have r, and it's negative 2 times negative 3, so it would be r to the positive 6. Then I just need to rearrange it. I'd need to bring my x to the 3 to the denominator and my r to the 6th. I have to have a numerator, so my numerator would be 1. For the 12, problem number 12, I had a lot of questions about this one. The fact that your denominator is negative really doesn't affect it. You can have a negative denominator, you just can't have a negative exponent. So the denominator is just fine. So we have 12. I'm going to just put a little bit of space here between everything and see how we can reduce. All right, so I just put a little bit of space in my fraction here, so you can kind of see how we have things. I would reduce my 12. I divide both the numerator and denominator by 3. Here I divide by an m, or take away an m from both the numerator and denominator. Here I take away 4y's from both the numerator and denominator. The answer in the end was a 4m to the 7th y to the 2nd over 3. And with that negative that I have right here for the 3, what I'm going to do is I'm going to write that negative right out in front. And I know it's kind of hard to see this answer, but I'm going to show it right out in front, because I usually, instead of showing it, and I did have this option of showing the negative over here by, oops, I guess it was here, over here by the negative 3. So I'm going to do this here for a minute here. I do have an option right now. I'm going to do it in red. I could have put the negative 3 with the denominator, but I think it's more, it can be seen more if you put it out in front of the fraction. So that's kind of what I'm advocating for, is to put it out in front of the fraction. So now I want to go over some radicals, what to do when we have radical values. So I'm going to have you finish the rest of this worksheet on your own. But I want to talk about what do we have when we have radicals. The denominator here is our root. So when we have a base, and it's raised to not just an exponent, but an exponent that's a fraction. The denominator is our root, or our radical. I'm going to call it root, and I'm going to put radical in parentheses. The numerator is our exponent, or our power. All right, our power. Raised to what power? So when we have 625 raised to the 3/4, what we want is we want 625 raised to the 3rd power, but we're taking the 4th root of it. Okay? Now, to tell you the truth, if I had this problem, 625 to the 3/4, what I would do is I would get a calculator, and I would go 625, and it's raised to the 3/4. So I'd put parentheses, and I'd go 3 divided by 4. So raised to the 3/4, and that's my answer. I know it's not a pretty answer there, but that'd be an estimate answer. I was kind of trying to see, do I have a whole number answer? And I don't, so I'd probably just leave it like that, since I didn't get like a nice, pretty, full, whole answer. So here, with this problems, we were simply saying, okay, we want you to show it with a radical instead of with these fractions. And so these are 3rd roots, and we have x to the 1st and y squared. That's just simply what we're looking for you to show. Here, I'm looking for simply the square root of 7. In this case, it's 6 to the 3rd, x to the 3rd, and we were talking about the cube root of everything. You could go ahead and find out what 6 to the 3rd is. I think it's 216, x to the 3rd, and we have the 3rd root of it. There might be a 3rd root to that. I'm not sure. No. All right. Here, we were talking about 5x raised to a -1, and then we're talking about the 3rd root of that. Well, this -1, what it does is it brings it into the denominator, our 5x in the denominator, and the 3rd root just kind of goes along with it. So this would be our final answer here. Couple more problems. Now these 4 problems were just about, can you put it back into the fractions, kind of doing something forwards and backwards. So this one I was just simply looking for 4½ a to the 6 halves, and b to the 5 halves. Now, I'm sure a lot of you can say, well, I know this answer is 2. I know this would be reduced to a to the 3rd, and I know this can't be reduced, so I would just have you leave it at b to the 5 halves. This type of problem is much better for problem 31, where you have 8 to the 1/3, x to the 9/3, and y to the 12/3. Now it makes sense. Well, this 8 to the 1/3, the cube root of 8 is 2. X to the 9/3, excuse me, would be x to the 3rd. Y to the 12/3 would be y to the 4th. So this is one of those points where it really helps you to say, oh yeah, I can see why you'd ask me to put it in those terms. All right, so let's do some more of these. Now we're just simplifying. Here, we're simply asking you, what is the square root of 9? Here, we'd be saying, what is the 6th root of 64 to the -1, and the 6th root of n? And actually, I think I would do this kind of a little bit differently. I think I would take 64 to the -1/6 and n to the -12/6. This actually turns out to be 1/2, and it's n to the 2nd in the end. And I know I'm kind of rushing for time here. This one I would do on a calculator. I would just plug into my calculator 36 to the 3 halves. So if I did that, 36 to the power of 3 divided by 2, we do get for an answer 216. So you can kind of see, oh, sometimes you do have a really quick answer. Well, hopefully we can come in class